Well, let's see if they do. Okay, so would you write the word cases right here? So what we're going to talk about is we're going to talk about solving special cases using matrices, and if you want, you can use your calculator on some of these. If you like doing those by hand, you're welcome to do them by hand, but I think you're crazy because one arithmetic mistake and you've got the wrong answer, and then you're going back anyway. So we already did quick draw and factor of the day, so we got that one done, and here's what I want you to take a look at. What we're looking at, and we've talked about these before, is we're looking at the point where the planes cross. And most of the time what happens is this case number 1. I've got 5 different cases of the way things can happen, and I think we've looked at this before. So this is what happens most of the time. We like it when that happens. Okay, if that happens, then we end up with them crossing at one single point. We're used to this reduced row echelon form right here, and we write down the answer as an ordered triple. Okay, that's what happens most of the time. In these two cases, in case 2 and case 3, we'll get something that looks like this. If you do all your row operations the right way, you might get to the point where the last row just says 0, 0, 0, 0. So this equation right here is a true equation, but it has infinitely many solutions. Okay? So the answers are defined in terms of one unknown variable. Then we can have 3 identical planes. And they have, again, infinitely many points in common. And you're going to end up with something like this. You try and put it in reduced row echelon form, and you can get the 1, 0, 0 or something like that. And then you just get a bunch of zeros here. So you've got two true equations. All right? So the answers are defined in terms of, would you underline the word 2 right here? 2 unknown variables. And then this is the way that we can have no solution at all. They could be parallel planes, they could cross 2 but not the other one and stuff like that. We might end up with something like this. There are lots of ways that this can happen and lots of different ways that the matrix can look once we try and reduce it. But you'll always end up with an equation that cannot be true. There's no way you can make it true. So on this one right here, what we're saying is 0, 0, 0, so no x's, no y's, and no z's, and you get a number. So remember, we usually use letters at the beginning of the alphabet to represent constants. So this is no x's, no y's, no z's. So this side is a 0, and the other side is a number that's not 0. Yeah?
Never mind, actually.
Okay. All right. So when there are infinitely many answers, as there are in case 2 and 3 above, so these guys right here, we get to choose an independent variable that can take on any real value. So we're just going to say whatever the variable is that we choose. We're usually going to choose z. And then we're going to write the other ones in terms of that particular variable. And it sounds complicated, but it's actually pretty easy. So I think you'll like the assignment today because I think there's 12 problems, and on 8 of them, it gives you the matrix in as close as we can get it to reduced row echelon form. And all you have to do is just interpret what it means. What's x, what's y, what's z, and stuff like that. So you'll notice that this last equation here says that no x's, no y's, and no z's. So 0 on this side of the equal sign equals 0 on the other side of the equal sign. So we're going to get infinitely many solutions. So what we're going to do is we're going to say z equals any real number. And then I'm going to think about what do the other equations say. It may not be in reduced row echelon form, but this actually means something. Remember, this is the x column, this is the y column, this is the z column, and for lack of a better phrase, that's the answer column. So this second row actually means this. It means y plus 0.5z equals -1. And the first equation means x minus 2z equals 4. So we're usually solving for what x is, what y is, and what z is. We've got z taken care of. Z can be any number. So we're just going to take this and we're going to rearrange it. We're going to just solve for y in terms of z. So I'm going to move this over to the other side by subtracting 0.5z. And I'm going to write down y is equal to -1 minus 0.5z. And I'm going to put a dotted circle around that. So think for just a second. What we're doing here is saying z can be any number you pick, and once you pick z, I can plug it in and I can tell you what y is. And then we're going to do the same thing for x. I'm going to move this to the other side by adding 2z. And I'm going to write x equals 4 plus 2z. And I'm going to put a dotted circle around that. And I'm saying, look, I don't know what x is, but if you can tell me what z is, then I'll tell you what x is. Luke.
So do we want it in the order of constant and variable?
Good question. That was what I was going to talk about next, so thanks for bringing that up. It is really personal preference. I learned, and we had a discussion about this a couple of weeks ago. I learned writing it down this way, and I kind of like that because what we're doing is we're saying y is going to be a -1, and then I adjust it by however much z is. So I like writing the constants first. If you want to write the variables first, that's totally okay with me. I think Miss Doty does it that way. I found my old linear algebra textbook, and it had it the way I'm going to write it. So this is still an ordered triple. So let's write down what x is. X is 4 plus 2z, comma, y is -1 minus 0.5z, and I'm okay with the variables there. And then we're going to do a comma, and then z is any real number. Now, we've got this written up here, but if you were to write it like this, it might be good to put everything in one place and just say z, any real number. Any questions? Yeah.
Why does z have to be real?
Because we're graphing it on a real three-dimensional plane, so it's got to be a positive or negative. It's got to be a rational number or a real number. It can't be imaginary. It wouldn't be on that three-dimensional plane. Good question. Anything else? Okay, let's take a look at the next one. Okay, if you look at the last row, you'll notice z is kind of missing. Anything would make that true, so we're going to say that this implies that z can be any real. You'll notice that on this one we're basically saying y is missing. Anything would make that second equation true, so we're going to say y equals any real. And then we're going to write down what the first equation means. This means an x plus 2 y's minus 3 z's equals 4. And then all I have to do is solve in terms of those two variables. So I'm going to subtract 2y. I'm going to add 3z. And then I'm going to write down the ordered triple. So the ordered triple is 4 plus, I'll do the y's first, minus 2y plus 3z, comma, y, comma, z. And then we just add y and z, any real numbers.
That's rad.
So Dane, I said advanced, but is it easy?
Yeah.
Still pretty easy.
So why is it?
Yeah.
Can we just not write real and just put any number since we know it has to be real?
Well, what if it's?
So the standard way to write this is any real number. Okay.
Can we do AR number?
Oh my gosh.
just do, like,
No, just write it down. I think you'll live.
Soul?
Okay, take a look at the next one.
Where are we gonna use
Can you just do
this?
infinity souls?
I'll answer
for
that later.
YZ?
Eyes up here. Okay. I'm hoping your eyes are drawn to that last one. Somebody raise their hand and tell me what it means. Do not say anything out loud. Think about it for just a second. What does it mean? Angela.
Z equals -3.
It means z equals -3. So now that we know what z is, let's write down what this other equation means. This one right here, remember we've got the x column, the y column, and the z column, and then we've got our answers right here. So this second row, it represents y plus 0.25z equals -2. And then this first row represents x plus 4y minus 5z equals 2. So let's just go ahead and solve this like we did on the other one. So I'm going to subtract 0.25z. Subtract 0.25z. Those are going to cancel, so I'm going to get y equals -2 minus 0.25 and then z. But z, remember, is -3. So if I throw that in there, I'm going to get -2 Negative times a negative is a positive, so it's going to be plus 0.75. So we get negative 1.25. So I've got the z right here. I've got the y right here. And then let's solve for this one. So I'm going to move the 4y over, so subtract 4y. I'm going to move the 5z over, so that's going to be plus 5z. So I get x equals 2 minus 4y plus 5z. And let's plug in what we've got. So this is going to be a 2 and then minus 4 times negative 1.25 and then plus 5 times z, and z is negative 3. And let's see what we've got here. So this is going to be 2. Negative times negative, that's going to be a plus 5, and that's going to be a negative 15. So we end up with x equals negative 8. So I've got those answers right there. We're going to write down the ordered triple. So this is going to be negative 8, comma, negative 1.25, comma, negative 3. And we're going to put a circle around that, and there we go. Okay, now just a quick word about this thought question at the end. So if we were to take this matrix right here, this augmented matrix, and say, how could we change something in here so that there are no solutions? Remember, no solutions occur when we get an equation that there's no way it can be true. So all we'd have to do here is put a 0 where the 1 is, and then it says no x's, no y's, and no z's. So this side of the equation is basically 0, and then the other side is a negative 3, and 0 doesn't equal negative 3, so there'd be no solution to that. Now, you can't just randomly put in numbers that you want, but there we go.